In this video, I will be discussing about integration by algebraic substitution. So here, we will concentrate to the integrals of irrational functions or with irrational integrands. Actually, employing this technique means a change in the variable of integration so that the irrational integrand will be transformed to one that is rational. So in this technique, the substitution involves only algebraic terms. And this is commonly known as algebraic substitution. The algebraic substitution to be made depends on the irrational integrand under consideration. Actually, no general rule can be given in order to accomplish the rationalization of the integrand. There are 7 types of these integrals. Type 1. When the integrand contains fractional powers of x only, we use the substitution z is equal to the nth root of x or the nth power of z, which is equal to x, where n is the least common denominator of the fractional exponents of x. So to illustrate this type of integral, let's have an example. What is the integral of the cube root of x minus the fourth root of x divided by 4 times the square root of x dx? So here, let us list down our irrational terms. The cube root of x here, which in the exponential form is x to the power 1/3, and also the fourth root of x. And the fourth root of x in the exponential form is x to the power 1/4. And also the square root of x in the exponential form, this is x to the power 1/2. Then we say that our n here is 12 because this is the least common denominator of this 1/3, 1/4, and 1/2. In other words, this is the number that can be divided by 3 or 4 or 2 here. Thus, we will use our substitution, which is z equals to the 12th root of x. Or in other words, this is z to the power of 12, which is equal to x. Thus, our x is equal to z to the power of 12. Then therefore, we can find our dx here. So, dx is equal to 12 times z to the power 11 dz. So therefore, this is our representation for x, and this is the representation for our dx there. And substituting that one to our integrand, we have the cube root of our x. And we know that our x is z to the power 12 minus the fourth root of x. And again, our x is z to the power of 12 divided by 4 times the square root of x. And x is z to the power of 12. But our dx is represented as 12 times z to the power 11 dz here. And simplifying this integrand by converting the radical form to its equivalent exponential form. So we have the integral of z to the power of 12 over 3 for this term here. And this is subtracted by z to the power of 12 over 4 for this term here. And this is divided by 4 times z to the power of 12 over 2 for this denominator here. But we still have the factor of 12 times z to the power 11 dz. Now, simplifying the fractional exponents, we have z to the power of 4 because 12 divided by 3 is 4. And this is subtracted by z to the power 12 over 4, which is 3. And divided by 4 z to the power of 6 because 12 divided by 2 is 6 times 12 z to the power 11 dz here. And simplifying our integrand further, we have the integral of z to the power of 4 minus z cubed times 3z to the power of 5 dz, because 12 divided by 4 is 3, and this exponent of 11 when subtracted by 6 is 5. So we have 3z to the power of 5 dz here. Now, factoring out this constant 3 in front of the integral symbol, we have 3 times the integral of z to the power of 9 minus z to the power of 8 dz, because we can distribute this z to the power of 5 to this binomial here. So when we multiply z to the power of 5 to z to the power of 4, we just add the exponent. So 4 plus 5, we have 9 here. And when we multiply z to the power of 5 by z to the power 3, we just add 5 to 3, which is 8 here. And therefore, we can easily integrate our integrand, that this is z to the power of 10 over 10 minus z to the power of 9 over 9 plus the constant of integration, say c prime. So we have here 3 over 10 times z to the power of 10 minus 3 over 9 times z to the power of 9 plus the constant of integration c, because when 3 multiplied by c prime, the product is still a constant. So substituting back our value of z, which is found here, this is equal to 3 over 10 times the 12th root of x, which should be raised to the exponent of 10, minus 1/3, because the lowest term of 3 over 9 is 1/3, times the 12th root of x. And the 12th root of x will be raised to the exponent of 9 plus the constant of integration c. So our final answer is 3 over 10 times x to the power 5, 6. Because when 10 is divided by 12, the lowest term is 5, 6 there. And this is subtracted by 1/3 to x to the power 9 over 12. And 9 over 12 is 3/4 in lowest term. And this is our final answer for this example number 1. Now let's proceed to our type 2 here. When the integrand contains fractional powers of a plus bx only, we use the substitution of z, which is equal to the nth root of a plus bx, or z to the power n, which is equal to a plus bx, where n is the least common denominator of the fractional exponents of a plus bx. So to illustrate this type, let us solve this example here. What is the integral of dx over x minus 2 quantity multiplied by the square root of x plus 2? So since we have an integrand having a fractional exponents for this binomial here, x plus 2, then we use the substitution z, which is equal to the square root of x plus 2. So squaring both sides in this equation, we have this z squared, which is equal to x plus 2. And subtracting both sides of the equation by 2, we have z squared minus 2 is the value of our x. So therefore, we say that our x is just z squared minus 2. And our dx is just the derivative of z squared, which is 2z. And since these are our representations for x and dx, then we can substitute these representations to our integrand here So we have the integral of 2z dz. So instead of writing dx, we will write its representation, which is 2z dz. And then we divide this one by our x. And we know that our x is z squared minus 2. But this will be subtracted by 2. And the whole expression will be multiplied by the square root of our x. And our x is z squared minus 2. And z squared minus 2, which is the value of x, will be added by 2 here. So removing the outer parenthesis here, we have the integral of 2z dz. And this is divided by z squared minus 4, because the minus 2 when subtracted by 2 is minus 4 here. And this is multiplied by just the square root of z squared, because minus 2 plus 2 is 0. And then we simplify further by taking the square root in our denominator here. We have only z, because the square root of z squared is just z. But we can cancel that one to our numerator because we have z here in our denominator. So this is the integral of 2z dz. This is the integral of 2 dz divided by z squared minus 4. And factoring out this 2 in front of the integral symbol, we have 2 times the integral of dz over the square of z minus the square of 2 here. So looking at our denominator, we notice that this is a difference of 2 squares. So here we use a representation for our constant a, which is 2, and our u is our z. Then therefore, our du is dz. So substituting these representations to our integrand, we have the 2 times the integral of du here. So instead of writing dz, we will write du over u squared minus a squared by substituting our representations for u and a. So by the integration formula 25 that we introduced in our video number 5 in this playlist, we have 2 times the integral of this one, which is 1 over 2a times the natural log of the absolute value of u minus a divided by u plus a. And this is added to the constant of integration, say c prime. So multiplying our 2 here, we have 1 over a, because this 2 and this 2 cancels each other. And this is multiplied by the natural log of u, and our u is z, and our a is 2. So by substitution, we just substitute back our original variables. So this is added to the constant of integration c, because when 2 is multiplied by another constant c prime, the product is still a constant. So we have 1 over 2 times the natural log of the absolute value of our z, but our z is the square root of x plus 2. So we have the square root of x plus 2 subtracted by 2. And this is divided by the square root of x plus 2, which is our value of z added to 2, and plus the constant of integration c. Then therefore, this is our answer for this example number 2. So let's proceed to our third type here. When the integrand contains the expression of the form x to the power m times the quantity of a plus b x to the power n raised to the exponent of r over s dx, where m, n, r, and s are integers, and this n and s are positive integers. And notice that m plus 1 over n is an integer or 0, then we use the substitution of z, which is equal to the s root of a plus bx to the power n, or z to the power s equals a plus b x to the power n. So to illustrate this type of integrand, let us solve this example here. What is the integral of x to the power of 5 times the square root of 1 plus x cubed quantity raised to the exponent of 3 dx? So expressing this radical factor to its equivalent exponential form, we have the integral of x to the power of 5 times 1 plus x cubed raised to the exponent of 3/2. So with that form, we can identify the values of our m, n, r, and s. That our m is 5 there, and our n is 3, and our r is also 3, with s which is equal to 2. And we also noticed that m plus 1 over n is equal to 5 plus 1 over 3, because our m is 5 and our n here is 3, and this is equal to 6 over 3, and the result is an integer here. Then therefore, we can use our substitution z, which is equal to the square root of 1 plus x cubed. And squaring both sides of the equation, we have z squared, which is equal to 1 plus x cubed. Then subtracting both sides of the equation by 1, we have z squared minus 1, which is equal to x cubed. Then raising both sides of the equation by 1/3, we have z squared minus 1 to the power of 1/3, and this x cubed when raised to the exponent of 1/3 is x. So our x is just the binomial z squared minus 1 to the power 1/3, and we solve for our dx, which is 1/3 times z squared minus 1 to the power negative 2/3, and by the chain rule, we need to multiply by the derivative of z squared, which is 2z. So therefore, our dx is equal to 2z dz, and our denominator here is 3 times z squared minus 1 to the power 2/3. So our representations for x is this one here, and for our dx is also this fraction. And using this substitution for z, which is the square root of 1 plus x cubed, so this is equal to the integral of our x to the power of 5, but our x is z squared minus 1 to the power of 1/3, but this is raised to the exponent of 5 times 1 plus x cubed, and 1 plus x cubed is z squared, so we have z squared raised to the exponent of 3/2. So instead of writing 1 plus x cubed, we will write its representation, which is z squared here, and our dx is the fraction of 2z dz divided by 3 times the z squared minus 1 to the power 2/3. So factoring out these constants here, in front of the integral symbol, we have 2/3 times the integral of z squared minus 1 to the power of 5/3, because when 1/3 is multiplied by 5, we have 5/3 here, and this will be divided by z squared minus 1 raised to the exponent of 2/3, because it is from this denominator. And then this is multiplied by z to the exponent of 3, because when 2 is multiplied by 3 halves, that is 3. But this is also multiplied by the remaining factor here, which is z dz. So therefore, we have 2 over 3 times the integral of z squared minus 1 raised to the exponent of 3 over 3 times z to the power of 4 dz. Because when z cubed is multiplied by z, the product is z to the power of 4. So distributing our factor of z to the power of 4 to this binomial, because this exponent is already 1, we have 2/3 times the integral of z to the power of 6 minus z to the power of 4. Then therefore, solving for the integral, we have 2/3 times z to the power 7 divided by 7 minus z to the power of 5 divided by 5 plus the constant of integration, say c prime. So distributing this 2/3 for this expression here, we have 2 over 21 times z to the power of 7. And this is subtracted by 2 over 15 times z to the power of 5 plus the constant of integration c. So substituting back our value of z, which is the square root of 1 plus x cubed, we have the square root of 1 plus x cubed, but this is raised to the exponent of 7. And this will be subtracted by 2 over 15 times the square root of 1 plus x cubed, but raised to the exponent of 5 plus the constant of integration c. Then, therefore, factoring the common factor here, we have 2 over 3 times the square root of 1 plus x cubed raised to the exponent of 5. So what remains is just 1 over 7 times the square root of 1 plus x cubed raised to the exponent of 2 minus 1/5 plus the constant of integration c. So simplifying this factor here, we have 2/3 times 1 plus x cubed to the power of 5 halves. And this will be multiplied by this binomial. And this binomial, when combined, is equal to a fraction with an LCD of 35. So this is 5 times 1 plus x cubed minus 7. And this is added to the constant of integration c. So multiplying these two denominators here, we have 2 over 105. And this is multiplied by 1 plus x cubed to the power of 5 halves. And this is multiplied by this binomial. So we have 5 plus 5x cubed subtracted by 7. So we have our final answer of 2 over 105 times 1 plus x cubed raised to the power of 5 halves. And this is multiplied by these terms of 5x cubed minus 2. So we have our answer for this example here. So now let's proceed to our type 4. When the integrand contains the expression of the form x to the power m times a plus bx to the power n quantity raised to the exponent r over s dx, where m, n, r, and s are integers and our n and s are positive integers, as well as m plus 1 over n plus r over s is an integer or 0, then we use the substitution of x to the power n times z to the power s which is equal to a plus bx to the power n. So to illustrate this type of integrand, let us solve this example here. What is the integral of dx over x cubed times 1 plus x cubed quantity raised to the power 1/3? Now moving this denominator here to the numerator, we have the integral of x to the power -3 times 1 plus x cubed to the power -1/3 dx. So here we can identify our values of m, n, r, and s. That our m is -3 and our n is 3 here, and our r is -1 with s of 3, because this 1 is our m and our n is also 3, and our r is -1 with s, which is 3. And we can check that our m plus 1 over n is not an integer, because our m is -3 plus 1 over 3. And we notice that this one is -2/3. And -2/3 is not an integer. So therefore, this does not belong to type 3. But if you add a fraction of r over s, where our r is -1 with s of 3, we have -1/3 here. And we know that -2/3 minus 1/3 is -3/3. And -3/3 is -1, which is an integer here. So since it satisfies the condition for type 4, we use our substitution, which is this one here, that this is x to the power of 3 times z to the power of 3, which is equal to 1 plus x cubed. And solving for z here, we have z cubed, which is 1 plus x cubed over x cubed, by dividing both sides of the equation by x cubed and raising both sides of the equation by 1/3, we have z, which is equal to 1 plus x cubed divided by x cubed here, but the fraction is raised to the exponent of 1/3. But in this substitution, we can subtract both sides of the equation by x cubed. So we have x cubed times z cubed minus x cubed, and the difference is equal to 1. So factoring the common factor here, we have x cubed times the binomial of z cubed minus 1. So therefore, our x cubed is equal to 1 over z cubed minus 1 by dividing both sides of the equation by z cubed minus 1 and raising both sides of the equation by 1/3, we have x, which is equal to 1 over z cubed minus 1 to the power of 1/3. So we have x, which is equal to z cubed minus 1 to the power of -1/3. Thus, solving for our dx here, we have dx, which is equal to the -1/3 times the binomial of z cubed minus 1 raised to the exponent of -4/3. So, simplifying our dx, we have negative of z squared dz over z cubed minus 1 to the exponent of 4/3. So these are our representations of x and dx here. And substituting these representations to our integrand, we have the integral of our x, but our x is z cubed minus 1 to the power of -1/3. but this will be raised to the exponent of negative 3. But our 1 plus x cubed is represented as x cubed times z cubed. So we have x cubed times z cubed raised to the exponent of negative 1/3. But our dx is represented by this one here. So this is multiplied by negative z squared dz over z cubed minus 1 to the power of 4/3. And simplifying our exponents, we have the integral of z cubed minus 1 raised to the exponent of positive 1, because negative 1/3 when multiplied by negative 3 is just 1. And this is multiplied by x to the power of negative 1 times z to the power negative 1, because when 3 is multiplied by negative 1/3, the product is negative 1. And so with these exponents here. And this is multiplied by negative z squared times z cubed minus 1 to the power of negative 4/3. But we know the value of our x, that our x is just this one here. So writing this one, our x z cubed minus 1 to the power of negative 1/3, this would be raised to the exponent of negative 1. But this z to the power negative 1 when multiplied by negative z squared is just negative z. But we still have a factor of z cubed minus 1 to the exponent of negative 4/3. Now, simplifying our exponents further, we have z cubed minus 1 multiplied by z cubed minus 1 to the power of 1/3. And this is multiplied by negative z times z cubed minus 1 to the exponent of negative 4/3. And multiplying these two binomials here, we have the integral of z cubed minus 1 to the exponent of 4/3, because this binomial is understood to have an exponent of 1. So 1 plus 1/3 is 4/3. But this is multiplied by negative z times z cubed minus 1 to the exponent of negative 4/3. But multiplying these two factors, we have the integral of negative z dz, because 4/3 plus the negative 4/3 is 0 here. And the binomial raised to the exponent of 0 is just 1. So we can easily integrate this integrand here. So this is negative z squared over 2 plus the constant of integration c. Then substituting back our value of z, which is this one here, we have 1 plus x cubed over x cubed, which is raised to the exponent of 1/3, but this should be raised to the exponent of 2 here. So we have negative of 1 plus x cubed to the power of 2/3, because when 1/3 is multiplied by 2, the product is 2/3, but this is divided by 2x to the power 2, because x cubed when raised to the exponent of 1/3, the result should be x, but x should be raised to the exponent of 2. That is why we have here x squared. And this is our answer for this example here. If you learned something today, please check out my channel for more videos like this and click subscribe. click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.